Uniform Section Hill Road Design Project by using bearing line survey data. In this session we shall see the design of hill road with uniform cross-section by using total station survey data. The design is based on the alignment of the center line of the road passing through the center of the median or central verge of the dual carriageway cross-section. The main screen is open. Select Working Folder Work located on the desktop. Next, select File option New and then New/Open Uniform Section Hill Road Design Project. As the workspace opens, the current selected tab is Create Project, the project name is Hill Road Design, survey data type is Total Station, select option Bearing Line Data and click on button Open Tutorial Example Data. Next, the bearing line data is accepted in MS Excel file. The message comes mentioning to open the MS Excel file and save as text file, tab delimited, star.txt, in the working folder, click on button OK. The present example bearing line survey data file name is bldata_file.xlsx may be saved as bldata_file.txt in the working folder. The next dialog box comes, click on button Yes. Next, close the MS Excel worksheet, the message comes, click on button No. The design workspace now has details as shown here. Next, we select the tab Process Survey Data and further select the tab page for Step 1 Ground Model. UTM data conversion is not selected, click on button Create Ground Model, the dialog box comes, click on button Browse. The selection box comes, select Saved Text Bearing Line Data File bldata_file.txt from folder Tutorial 5.3 Hill Road with bearing line data within working folder Work, click on Open. The data from MS Excel worksheet file saved as text data file is displayed in the dialog box, click on button Extract Data. The message comes informing about creating if survey data file survey.txt in the format of total station data and alignment data file alignment.txt containing list of horizontal intersection points with default radius at all the HIPS, click on OK and click on button Close. The ground model is created and saved in model files model.fill and model.lst, the message comes, click on button OK, next, the ground model can be drawn. The list displays the name of survey feature as OGL, click on the color box of this survey feature, as the color box comes select the color as desired, click on button Apply to All. As the color is assigned to the survey feature OGL, click on button Draw, the survey feature is drawn as the ground model. Next, we select the tab Step 2, Triangulation, click on button Create Triangulation Model, as the process box comes click on button Proceed. As the process is over the message comes mentioning about the output, click on button OK. Next, we select the tab Step 3, Contour, click on button Create Contour Model, as the process box comes click on button Run. As the process of creating of contours is finished click on button Save as shown below. Next, select icon from the bottom system bar and click on Quit to close the contour window. Next we draw the contour model and the contours are displayed. Next, we select tab Hill Road and the current page is for Step 4 for the design of horizontal alignment of the center line of the road. We select the option Halon Coordinate Inputs Traverse IPS. First the list of coordinates as traverse intersection points are processed to create the Halon data. Next the Halon data will be processed to design the horizontal alignment of the proposed road center line. The coordinate data is displayed and we click on Proceed. The design is done and the design report is written in file halonment.rep. Next we click on button View Halen Design for string M001 and display Shenage and details on the alignment string. Next we select step 5 for design of vertical profile of the road center line to choose single carriageway cross section type TCS07. The ground long section is created as model design and string E001 by picking up ground elevations from the triangulation file HDS001.fill by following the coordinates at each Shenage station of the horizontal alignment of string M001. Next we select step 6 for design of vertical profile of the road center line. Draw ground long section and make the grids displayed over the ground long section, and as it is tutorial example data, the option for vertical profile design process via line design data is already selected. The new interactive via line design was described in the last chapter. We got the report file vialignment.rep. At the end of the report there was 300 via line data which we can copy and paste in the left panel of the workspace. Written in file select process via line design data. Click on button proceed. As the process comes once again we click on proceed. After the data is processed the message comes informing about the report file. Click on button OK and finish. As we are back to the previous workspace, we click on button Next, draw vertical profile. We click on button vertical details on, and the vertical details are displayed along the design vertical profile of the string M001. Next we select step 6, select cross section. We click on TCS07 and see the selected typical cross section type for applying on entire length of the road from start Shenage to end Shenage. Step 7 to define cross section, interface, and create cross section. The current page is to define cross section dimensions for median or central verge, main carriageways, earthen shoulders, or sidewalks, left and right service roads as applicable by following the typical cross-section type schedule for various Shenage sections as done in the last step. We can change values for various items as desired. We click on button Save Data. Next, we select the page interface to create data for stepped embankment slopes on left and right hand sides in cut and fill situations. The interface strings will be created as string I002 along the outer edges of the carriageways. Next, we select the page to create cross-section. We click on button Process Cross-Section Data. The process box comes with list of batch processes in proper sequence. We click on button Proceed to process each step with the related data as displayed in the lower part of the process box. Every time we click on button Yes, to draw the strings after all the processes are over, and finally we click the button Finish, and next all the strings which are just created are drawn as shown in the display. The entire design is now displayed on the plan window of the screen. We click on button Create Cross-Section Drawings. As the process is over, we select a desired shehnage from the list of shehnage sections to view the plan and the related cross-section. Next we select Step 8 to define pavement layers separately for the left and right carriageways of the main road. The data is displayed for pavement layers in main carriageways on the left and right throughout the alignment of the road. If we want to modify the data, the same may be done in the display of the data, or alternatively by clicking the button Define Pavement Layers and modify the data for each shehnage section by selecting from the schedule, loading default data, saving the data for each schedule. Next we click on button Process Data to create the pavement layers in the road cross sections. Next, we select Step 9 for estimation of quantities for earthwork and pavement layers. The default data is displayed on the screen. We can make modifications in various values, if desired. We click on button Process Data. Next, Step 10 to create project drawings for construction. The first page is for alignment schematics. We skip process data and to create the drawings for horizontal and vertical alignments in 2 successive processes. Next, we select the page plan to create plan drawing for various strings listed in the box. Next, we select the page profile to create profile drawing for various strings listed in the box. The start and end shehnages are already displayed by taking from the previous design steps. The default length of road per sheet is always for the full length of the road alignment. This may be changed to 1000, in case the length of 1 km per sheet is desired. The horizontal scale is to be given suitably to fit the drawing to the length of the drawing sheet. The vertical scale should be 1/10 of the horizontal scale. We click on button Process Data to create the drawings. Next, select the page cross-section to create cross-section drawings at a given interval for the given length of the road. The start shehnage, end shehnage, scale, sheet size, and other data are given in the page. We can modify the data if desired. We click on button Process Data and a set of cross-section drawings are created. Finally, we select Step 11 to view various data files, design report files and design drawings now available with us. Click on button Create Update Project Data File. We can view the project data file, survey data file and various design report files by using respective buttons. We can view the design drawings in the CAD viewer by selecting from the list in the CAD viewer and save the drawings by selecting a desired format. This is the end of the current session for the design of Hill Road by using bearing line data, and we close the workspace by saving the project data file. Thank you.